Hello and welcome back. Today we're going to be talking about solving a linear system by graphing. The objectives are that by the end of this video, you should be able to check a solution to a linear system and solve a linear system by graphing. So what is a linear system? A linear system is two or more linear equations that contain the same variable. For example, the two equations y equals 3x minus 5 and 2x plus 3y equals 7 represent a linear system, because there are two linear equations, y equals 3x minus 5 and 2x plus 3y equals 7. And these two equations contain the same variables, x and y. A solution to a linear system is an ordered pair, x comma y, that can be substituted into both equations that will make both equations true. For example, is 2 negative 1 a solution to the following linear system? 3x minus 4y equals 10. We're going to substitute 2 in for x and negative 1 in for y. So we get 3 times 2 minus 4 times negative 1 equal to 10. 3 times 2 is 6, minus 4 times negative 1 is plus 4 equal to 10. 6 plus 4 is 10, equal to 10, which is true. So 2 negative 1 is a solution to the first equation. We still have to check 2 negative 1 into the second equation. So 2 equals 2 times y, which is negative 1, minus 5. So 2 is equal to 2 times negative 1 is negative 2 minus 5. So 2 is equal to negative 7. This is not true. So 2 comma negative 1 is not a solution to the linear system. Go ahead and try this one on your own, pressing pause, and when you're ready to see the answer, please press play. We're going to check to see if 0, 3 is a solution the same way we did in the previous example. We're going to make 0x and 3y, since our ordered pairs are always x comma y. So we put 0 in for x and 3 in for y. 0 equals 3 minus 3. 3 minus 3 is 0, and 0 does equal 0, so 0, 3 is a solution to the first equation, but it has to be a solution to the entire linear system, meaning it has to work for the second equation as well. So we need to check the second equation. 3 times y is 3, plus, equals 2 times x, which is 0, plus 9. 3 times 3 is 9. 2 times 0 is just 0. Plus 9 is 9. 9 does equal 9, so 0, 3 is a solution to this second equation. Since 0, 3 is a solution to both equations, you would say yes, 0, 3 is a solution to the linear system. Here's one last one for you to try. Please go ahead and pause the video. Check to see if 5, negative 2 is a solution. And press play when you're ready to see the answer. Again, for this one, you put negative 2 in for y. And 5 in for x, giving us negative 2 equals negative 2, which is true. We have to check the second equation, so we get 5 equals negative 2 minus 3. So 5 equals negative 2 minus 3 is negative 5, which is not a solution to the second equation. Since this ordered pair does not make both equations true, that means that 5, negative 2 is not a solution to the linear system. Now that we've checked solutions to linear systems, we're going to learn how to find the solutions to linear systems by graphing. The way we're going to go about finding the solutions to linear systems is we're going to graph both of the equations on the same coordinate plane. I'm always going to convert my equations into slope-intercept form, and I'll use slope-intercept form in order to, again, graph the equations. Second thing you're going to do is you're going to find the point where the two lines intersect. The point of intersection is the solution. You're going to get an x comma y value. That's going to be your solution to the linear system. It's an expectation that you will always check your solution by substituting the values of x and y that you found from your ordered pair of the intersection back into both equations. So we're going to go ahead and solve a linear system by graphing, and the way I'm going to do that again is by getting both equations in slope-intercept form first. So I'm going to get both equations to be y equals mx plus b. Let's look at the first equation. To get y by itself, I'm going to box the y, and I need to get rid of everything but the box. Remember, the way we solve equations is by going in SAD MEP order, or in reverse PEMDAS. And we're undoing operations, again, in SAD MEP order. So we look at 10 minus 2 times y. We can't get rid of the negative 2 times y because that would be multiplication and division. We need to first get rid of any subtraction or addition that's on the side. We do have a 10, and it's a positive 10, so we can get rid of that by subtracting 10 from both sides. Since negative 2x and negative 10 are not like terms, it leaves us with negative 2x minus 10 is equal to 10 negative 10 will cancel, and we're left with just negative 2 times y, or negative 2y. I now need to get the y by itself, but it's a negative 2 times y. So I can undo that negative 2 times y by dividing every term on both sides by negative 2. Negative 2 over negative 2 leaves me with a positive 1x. Negative 10 over negative 2 gives me plus 5 is equal to negative 2 over negative 2 is a positive 1y, which I can rewrite as y equals x plus 5. Let's take a look at the second equation. Second equation is easier to get y by itself because all I have is a 2 times y, so I can get rid of the 2 on both sides by dividing both sides by 2, leaving me with, in the end, y equals a negative 1/2 x. Now the reason that's 1/2 is because the coefficient is 1 if it's not written. So negative 1/2 x plus 4 over 2 is 2. Now that we have both equations in slope-intercept form, I can graph both these equations. I'm going to start with the first one. Remember, it's y equals mx plus b. And our m is a 1x because the coefficient is 1 if it's not written. So, my b I always plot first, so I'm going to plot positive 5. And my rise over run is 1 over 1. So I'm going to go up 1 to the right 1. Now, when we're solving by graphing, especially by hand, we're going to want to plot every single point possible that'll fit on the graph. So I went up 1 to the right 1 because my rise over run again was 1 over 1. And I'm going to go up 1 to the right 1 again, and up 1 to the right 1 again. I'm also going to go back to the y-intercept, and I'm going to go down 1 to the left 1, because that's the opposite direction, and it still creates the same straight line. So down 1, left 1, down 1, left 1, down 1, left 1, and so on until I get to the end of the graph. Then I'm going to connect all of my dots with a straight line. Now our straight line goes on forever because our domain was not specified. Okay, now that we have our first graph, let's go ahead and plot the second one. Y equals negative 1/2 x plus 2. So our y-intercept is positive 2, and in this case, our rise over our run was a negative 1/2. Now a negative 1/2 means we can go down 1 to the right 2, down 1, right 2, down 1, right 2, down 1, right 2. Or we can go up 1 to the left 2, up 1, left 2, up 1, left 2, up 1, left 2. Either direction I go, it still creates the same straight line. Now what we're going to look for, now that we've plotted both lines and every single point that'll fit on the graph, we're looking for the point where the two lines intersect. That point will be our solution. So if you'll notice, I'm going to write this in red, this point right here, this is our solution to the linear system. Let's go and write the ordered pair for that point. The solution to this linear system is -2, +1, 2, 3. So our solution is -2, +3. Now if you'll remember, in our instructions, I asked you to always check your work. And the way we're going to check our work is checking to see if -2, +3 is a solution to both equations. So I'm going to put 3 in for y. Remember, it's x comma y. I'm going to put 3 in for y equal to 1x, or x is -2, plus 5. Again, I'm substituting that point into my first equation. So 3 is equal to -2 plus 5 is 3. So our solution checks out for the first equation. Let's check our solution for the second equation. Y, which is 3, is equal to -1/2 of -2 plus 2. So 3 is equal to -1/2 of -2 is a +1, because -2 over 1, we multiply the tops, -1 times -2 is a +2, over 2 times 1 is +2, and 2 over 2 is 1. So I get 1 plus 2. So 3 is equal to 1 plus 2, which is 3. Notice, the solution that we found is indeed a solution to both equations. So it is a solution to the linear system. And again, the way we found that was by graphing both equations on the same graph and finding the point where they intersect. Go ahead and try to solve this linear system on your own, pressing pause, and when you're ready to see the answer, please press play. Alright, solving the first equation, I got y equals 1/2 x plus 0. I wrote the plus 0 so that I could have a y-intercept. Since there was no y-intercept listed, it's understood, again, to be 0. For the second equation, I got y equals -2x plus 10. Then you plot both equations. For the first one, 0 is our starting y-intercept, then we go up 1 to the right 2, and we do that repeatedly until we filled up the entire graph. We also go down 1 to the left 2. And we connect all of our points with a straight line. For the second equation, we got 10, so 8, 9, 10 as our y-intercept, and our slope was -2, so down 2 to the right 1. And so on. When we connect the lines, or the dots, for our second equation, we can see pretty immediately what our solution to the equation is going to be. Our solution to the equation in this case should be +4, +2. Again, we're always going to check our solution to make sure we did everything correctly. So if I put 2 in for y, 2 times 2 equals 4 in for x. 2 times 2 is 4, and 4 does equal 4, so that one. For the second equation, we get 2 times 4 plus 2 equal to 10. 2 times 4 is 8, plus 2 equal to 10. 8 plus 2 is 10. 10 does equal 10, so our solution checks out for the second equation as well. Unusual examples for you to try. Go ahead and try to find the solution to this linear system on your own, pressing pause, and when you're ready to see the answer, please press play. Now, if you run into a problem, don't be dismayed. Just go ahead and give it a try anyways, and think about whatever you get. what that means as far as the number of solutions where the solution goes. I went ahead and solved and graphed both equations, and if you look at it, one's in red, one's in blue. Where do the two lines intersect? What's the solution? The answer is that there is no solution to this linear system. You might be asked, well, why is there no solution? Because the lines are parallel, and parallel lines never intersect. A way you can tell two lines are parallel without even having to graph the equation is by looking at their slopes. If both lines have the same slope, then they're going to be parallel, which means they will never intersect. But there's one little piece of information at the end: the y-intercept also has to be different. Let's take a look at an example where the y-intercept's the same and so is the slope, and let's see how that affects the number of solutions. Again, go ahead and try to solve this linear system on your own, pressing pause. When you're ready to see the answer, please press play. I went ahead and graphed the red line, or the first graph in red, and I made the dots really big because I want you to see something. As I graph the second equation, y equals 2x plus 4, I plot my y-intercept, which is 4, I go up 2 over 1, up 2 over 1, or I go down 2 to the left 1, down 2 to the left 1, down 2 to the left, down to the left, down to the left, down to the left. And you notice, as I graph the second equation, it lands on top of all of the points from the first equation. So how many times will these two lines intersect each other? Now keep in mind, the lines go on forever. Well, if I draw a line straight on top of the other one, they're going to intersect each other everywhere. So how many solutions is that? The answer is that because they're touching or intersecting each other everywhere, there's going to be infinite solutions. And again, the reason is because when we graph both equations, the lines end up on top of each other. They touch all of the exact same points. Based on the previous examples that we just got through working, please tell me how many solutions each one of these systems contain. Pause the video, write down your answers, and press play when you're ready to see the answer. The first one, we're assuming it represents two different lines, one on top of the other. So this one would have infinite solutions. The second one, notice the lines are parallel to each other. They have the same slopes. You could have counted rise over run to verify that. So this one would have no solution. And the third one, they intersect each other at just one point. So for the third one, we would say that there would be one solution. Again, the reason for the first one we could assume there were infinite solutions is because we were told in the beginning that every graph shows two different equations. Since this graph showed two different equations, we were left to assume that one equation was on top of the other, because again, they told us that the graph should be showing both equations. So that ends today's lesson on solving linear systems by graphing.